Once we're familiar with the trig functions, sine, cosine, tangent, secant, cosecant, cotangent, um, we know exactly what they represent. We've worked with them a little bit, so we don't have to think too hard about what they are. We're ready to look at some special angles that we'll be able to use um, for a long time. We'll get a lot of mileage out of them. They'll be really helpful for just analyzing trigonometry at the beginning, and then we'll expand from these basic simple angles later. So the first angles that I want to talk about are 30 degrees and 60 degrees. And this comes from a right triangle that I have in mind, a 30, 60, 90 right triangle, which you may have looked at before. To get to that triangle, though, I want to start out with an equilateral triangle. So remember, equilateral means all the angles are equal, all the sides are equal. So what is the measure of each angle in an equilateral triangle? 60, because 180 divided by 3 is 60. So we're going to take this equilateral triangle, and I'm going to split it right down the middle. And so when I do that, it breaks into two different triangles, both of which are 60, 90, and 30 degrees. So 30, 60, 90 triangles. So now if I go back to my first equilateral triangle, and I decide to make the sides have a length 2, which I have the freedom to choose whatever length I want for those and make that thing however big I want. I'm going to choose the sides to be 2 because that will be convenient here. So if I do that, then once I split it in half, the bottom has a length of 1. So in my 30, 60, 90 triangle, I've got a hypotenuse of 2 now, a base of 1, and then I just need to figure out what the height is, the altitude of that triangle. The Pythagorean theorem helps me to do that. If you set it up, a squared plus b squared equals c squared, then you have 1 squared plus the height squared equals 2 squared. You can subtract 1 from both sides, and you get that the height squared equals 3, so the height is square root of 3. And now we can figure out what all of the trig functions are evaluated at 30 degrees and 60 degrees. So if we think of sine of 60 degrees now, that's opposite over hypotenuse, or you can think of it as y over r. And so we see that that's root 3 over 2. And if we want cosine of 60 degrees, that's 1 over 2. If we want tangent of 60 degrees, we can see that that's root 3 over 1 because it's opposite over adjacent, or y over x. And then we know how to get the other 3 trig functions by just taking the reciprocals of these first 3. So secant, cosecant, cotangent, we've got as well now. So that's pretty simple. We got everything for 60 degrees. All 6 trig functions evaluated at 60 degrees. We can do the same thing for 30 degrees. But I want to point out something kind of special here. Look at sine of 30 degrees, for example. Sine of 30 degrees, so you start at 30 degrees and you take the opposite over the hypotenuse. That's the same as starting with 60 degrees and taking adjacent over hypotenuse. So the sine of 30 degrees is the same as the cosine of 60 degrees. And this always happens, no matter what those 2 angles are. They don't have to be 30 and 60. If we start with the right triangle, and let's say we have an angle A, then the other angle in the right triangle has to be the complement of A, 90 degrees minus A. And it's always true that sine of 90 minus A equals cosine of A, just because of the way those trig functions are defined. So because of that, we call sine and cosine cofunctions. And so tangent also has a cofunction, which is obviously cotangent. And it works the same way. If you take tangent of 90 minus A, it's the same thing as cotangent of A. And if you take, if you take secant of 90 minus A, and that's cosecant of A. And it's just because of how the ratios naturally match up with each other. So that's cofunctions. That's pretty useful sometimes. It's a nice, it just really is nice, quick, and precise terminology that we can use to represent something that's slightly complicated. So now we know how to figure out all the trig functions for 30 degrees as well. We can just take their cofunctions evaluated at 60 degrees, and then we have the values that we need.